In this video, I'll explain partial differential composite functions, that is, chain rule of partial derivative. Suppose you have a function z which is a function of u and v. U and v in turn, these two are functions of x and y. Then f is called as a composite function of x and y. Thus, z is a function of u and v, and u and v in turn they are functions of x and y, hence z is a composite function x and y. So in that case, if you want to find out the partial derivative of z with respect to the independent variable x and y, it is given by dou z by dou x equal to dou z by dou u, first with respect to u, then u with respect to x, plus similarly dou z by dou v, first with respect to v, then with respect to x. Then similarly dou z by dou y with respect to the second variable, dou z by dou u into dou u by dou y plus dou z by dou v into dou v by dou y. So when you are partially differentiating with respect to x, you can see here you will get the independent variable only x. With respect to y, it is separate formula. So these two formulae are called as chain rule. This is chain rule for the partial derivatives of composite function. Similarly, you can have z as a function of x, y, and x and y in turn they are functions of u and v. So in that case, the partial derivatives are given by dou z by dou u now, because z is a function of x and y. X and y are functions of u and v. Therefore, z is a composite function of uv. So in that case, independent variables are u and v. So partial derivative of z with respect to the first independent variable u is first partial derivative of z with respect to x, then partial derivative of x with respect to u. Nowhere total derivative in d by dx will come here, because this function is a function of two variables. Here again x is a function of two variables. So whenever you have more than one variable, it is always partial derivative. That is one way to remember. Plus dou z by dou y into dou y by dou u. Similarly, dou z by dou v equal to dou z by dou x into dou x by dou v plus dou z by dou y into dou y by dou v. So these two formulae are also as chain rule for the partial differentiation. So based on these two rules, there will be some problems which will be asked. Let us see the problems. See here the first problem. If z equal to problem f of u comma v and u equal to x square minus y square, v equal to 2xy, then prove that zx square plus zy square equal to 4x square plus y square into zu square plus zv square. That is the partial derivatives. Chain rule you have to apply, because z is a function of here u and u and v are in terms functions of x and y. Therefore z is a composite function of x and y. So I need now dou z by dou x, that is zx, equal to dou z by dou u into dou u by dou x plus dou z by dou v into dou v by dou x. So which is equal to dou z by dou u. So I don't know the function explicitly not given here. Dou z by dou u, write it as it is. Dou u by dou x, derivative of u with respect to x partially. So x square, it is 2x. Anyway, y is a constant. Plus dou z by dou v into dou v by dou x. So with respect to x, 2y is a constant, derivative of x is 1. So this is one thing. Zy equal to dou z by dou y, which is dou z by dou u into dou u by dou y plus dou z by dou v into dou v by dou y, which is equal to dou z by dou u, you keep as it is. Now dou u by dou y, which is minus 2y, because x square is a constant, minus y square derivative is minus 2y, plus dou z by dou v into dou v by dou y with respect to y. 2x is the constant, derivative of y with respect to y is 1. So we got these two values. Now you have to find out, you have to prove that zx square plus zy square. Therefore, square these two values and add them. So I will get here zx square plus zy square equal to this value zu I will write to 2x plus zv into 2y whole square plus similarly here zu into minus 2y plus zv into 2x whole square. So that is easier to simplify instead of writing dou z by dou u. So a plus b whole square formula, that's it. 4x square plus zu square plus 4y square zv square plus 2ab. So 2 2s are 4, 4 2s are 8xy zu into zv plus similarly this one 4y square zu square plus this is 4x square 4x square zv square plus 2 2s are 4, here it is minus you will get 8xy into zu into zv. Therefore, this term cancels now, zu into zv cancels. So, this is equal to z 4x square. You take common from these two terms, then you will get zu square plus zv square plus here 4y square common, then you will get zu square plus zv square again from these two terms. Again zu square plus zv square common, then you will get 4x square plus 4y square. This is the required RHS. This is zu square plus z square is equal to 4 into x square plus y square. The same thing we got back. This is using the concept of partial derivatives of composite functions, that is chain rule for composite functions. One more problem. This is your u equal to f of x minus y, y minus z, z minus x. Then you have to prove that ux plus uy plus uz equal to 0. So here in this case, they have not given it in terms of new function. Here u is given, which is a function of x minus y, y minus z, z minus x. So we have to take these values as a new variables like p equal to x minus y, q equal to y minus z, and r equal to z minus x. You can take small letters as well. Therefore, u is a function of p, q, r. Then p, q, r in turn they are functions of x, y, z. Therefore, u is a composite function of x, y, z. So you have to use the chain rule. Dou u by dou x is equal to. So you can use now of u, here you have f. You can use either f or u. So it is dou u by dou p into dou p by dou x plus dou u by dou q into dou q by dou x plus dou u by dou r into dou r by dou x with respect to x only. When you are finding it with respect to x, everywhere it is with respect to x here. So dou u by dou p, dou u by dou p as it is, dou p by dou x is 1 plus dou u by dou q into dou q by dou x with respect to x it is 0 plus dou u by dou r into dou r by dou x with respect to x it is minus 1, because z is a constant, derivative of x is 1 with a minus sign, so it is minus 1. Similarly, you have to find out dou u by dou y, that is equal to, I won't write the formula again, same dou u by dou p into dou p by dou y. So with respect to y it is minus 1 plus dou u by dou q into dou q by dou y. So it is 1 plus dou u by dou r into dou r by dou y. There is no y term, both are constant, therefore 0. Similarly, dou u by dou z equal to, with respect to z now, dou u by dou p into, with respect to z, x and y are constant, so it is 0 plus dou u by dou q into dou q by dou z, so it is minus 1 plus dou u by dou r into dou r by dou z is 1. So now you have to add all the three. So what happens? You see ux plus uy plus uz, which is equal to, here you have dou u by dou p, one value. This is minus dou u by dou p, which cancels. Similarly, anyway, this is 0, dou u by dou r, and here you have plus dou u by dou r. That cancels. Dou u by dou q, here in this case, minus dou u by dou q. All values will get cancelled. Therefore, the answer is 0. Hence, we got ux plus uy plus uz to 0. This is the chain rule for the composite function of partial derivative. I hope you understood the concept. Thank you for